Dear friends, today we are going to discuss a very significant class of the phylum Mollusca, what we call as the Cephalopoda. The cephalopods are entirely marine and are more highly organized than the other mollusks. Well-known living forms are the cuttlefishes, the squids, paper nautilus and the pearly nautilus, whilst among extinct types are known as the belemnites, ammonites and goniatitis. Existing forms are always bilaterally symmetrical. The head is well marked and is separated from the body by a constriction. It is especially characterized by the presence of a circle or arm-like or lobe-like processes around the mouth. These processes are provided either with the sucking discs or with the tentacles and are used for seizing food and in locomotion. Behind the head is a muscular tube termed as the funnel, which opens in front to the exterior and behind into the mantle cavity. This may be either a perfect tube or may be formed by the apposition of two trough-like lobes. The arms around the mouth have been regarded as part of the foot and the funnel as representing the remainder of it. The name Cephalopoda is due to the view that the forefoot has grown around the mouth and is divided up into arms or lobes. On the upper surface of the head there are two large, which except in Nautilus are almost as highly developed as invertebrate animals. The mantle is formed by a single fold of the skin which passes quite round the body. On the upper or dorsal surface of the fold is very shallow, so that the mantle cavity exists mainly on the under surface. The feather-like gills are placed in the mantle cavity. In the Dai Brancs, that is the cuttlefishes etc., there is one pair. In Nautilus there are two. Water flows in at the sides of the mantle cavity and can be forced out through the funnel by means of the contraction of the walls of the mantle cavity. In the dibranchiate cephalopods, there is a gland known as the ink sac, which secretes a black fluid, that is sepia. The duct from this gland opens with the anus into the mantle cavity. The ink is ejected at times and passes out through the funnel, rendering the water cloudy and by this means facilitating the escape of the animal from its enemies. Just within the mouth there are two jaws which have the form of a parrot's beak and are either horny or calcareous. An odontophore is also present, but the arrangement of the teeth is less variable than the gastropods and is of little value for systematic purposes. The heart consists of a median ventricle and of lateral auricles, which are either 2 or 4 in number. According as there are 2 or 4 gills, the nervous system is remarkable in that the ganglia are close together, forming a central mass. One part is placed above the esophagus and is connected by cords with the other part beneath it. This central nervous system is covered by a cartilaginous ring and gives off nerves into the arms, viscera, etc. The sexes of the cephalopods are always separate and show external differences. In some genera there is no shell, but when present it may be external or internal. In the latter case, it is usually placed in a sac formed by folds of the mantle on the dorsal side. The Cephalopoda are divided into three orders, namely number 1 Nautiloidea, number 2 Ammonoidea, and number 3 Dai Branca. The first and the second sometimes grouped together as the Tetrabranchia also. Coming to the first module, that is order Nautiloidea. In Paleozoic times, the nautiloid cephalopods were very abundant, but at the present day, the only representative of the group is Nautilus. This possesses two pairs of gills and two pairs of auricles. No ink sac is present, and the funnel is not a complete tube, but is formed of two separate parts. Around the mouth are numerous lobe-like processes which are given off from the margin of the head. These represent the arms but do not bear suckers, as is the case in Dai Brancs, but tentacles which can be retracted within the sheaths. The hood is a structure formed by the enlargement of the outer lobe of the foot and serves to close the aperture when the animal withdraws into the shell. The jaws are calcified and are not uncommonly found as fossils. The eyes are of simple structure consisting of a hollow chamber with a pinhole opening without lens or cornea. A shell is present in all the nautiloids and is always external. It consists of a tube which tapers to a point at one end and may be straight, arced or spiral. In the spiral forms, the whorls may be separate or in contact throughout. Commonly, they are all in one plane, but in some cases, they form a helicoid spiral. In some genera with spiral shells, the whorls only just touch, but in others, the latter whorls partly or entirely overlap the earlier ones. Sometimes, as in Lithoides and Discitoceras, the lateral part of the shell becomes straight and separated from the spiral part. The body of the animal occupies the last or the body chamber, to the walls of which it is attached by the mantle and the muscles. In Nautilus, there are two oval muscular impressions, one on each side near the last septum and the inner side of the whorl. These impressions are marked by faint concentric lines. The muscles are connected both above and below by a band of fibers called as the annulus, which likewise leaves a mark on the shell. In Nautilus, the funnel is placed at the external margin of the aperture, so that this part of the last chamber is regarded as ventral. All the chambers except the body chamber are filled with gas, giving the buoyancy to the shell. The shell grows by the addition of material at the margin of the aperture. After a certain period of the body of the animal moves forward and a new septum is secreted behind it, thus cutting off a new air chamber. This movement occurs after a period of growth and is not related, as some have supposed, to periods of reproduction, since it is only after the shell is completed that reproduction begins. In Nautilus, the last air chamber of the completed shell is usually somewhat smaller than the preceding one. All the air chambers are traversed by a slender cord-like prolongation of the posterior end of the body, containing arteries and known as the siphuncle. The position of the siphuncle varies in different genera. In Nautilus, it pierces the septa at or near their centers. In others, it may be near either the external or the internal margin of the whorl. In the modern Nautilus, the siphuncle has only a thin calcareous covering, but in many fossil nautiloids, it is completely invested by a calcareous tube. In some Paleozoic genera, for example Actinoceras, the interior of the siphuncle is partly filled up with calcareous deposits. The septa are often prolonged in the form of funnels around the siphuncle so as to ensheath it more or less completely. They may be short or may reach from one septum to the next or even farther. These funnels are termed as septal necks. In nearly all the Nautiloidea, they are directed backwards, that is retrosiphonate. The aperture of the shell has in some cases a simple margin being either straight or slightly curved. In others, processes are given off from the external margin or from the sides. In Nautilus, there is a sinus at the ventral or external margin where the funnel lies, and the lines of growth on the shell are correspondingly curved. In some fossil nautiloids, that is the Phragmoceras, the sinus is at the inner margin of the aperture, which was therefore presumably ventral. In a few forms, that is the Gomphoceras, the aperture, owing to the inward growth of the margin of the body chamber, is constricted. The line where the edge of the septum unites with the outer or tubular part of the shell is known as the suture line. Obviously, this will be only seen when the shell is removed, but fossil forms frequently occur as casts, and in this case the sutures are clearly shown. One of the chief characters of the shell is in the Nautiloidea is the simple form of the suture lines. Usually they are either straight or only slightly undulating. Coming to the second module, that is the order Ammonoidea. The ammonoids are quite extinct and include the ammonites, Goniatitis, etc. The shell is generally coiled into a plane spiral, and as a rule, the suture lines show complicated patterns. The siphuncle is at the margin of the shell, generally at the outer, but in one upper Devonian group, that is the Climenidae, at the inner margin. It is usually more slender than in the nautiloids and does not contain internal calcareous deposits. The septal necks in the ammonoids are directed forwards, that is prosiphonate, except in some of the earliest chambers. In the Climenidae, some goniatites, on the other hand, they point backwards as in the nautiloids, that is retrosiphonate. But in the more advanced types of goniatites, they are transitional. A small collar-like part of projects in front of the septum, but the main part of the septal necks extend backwards. The form of the suture lines varies considerably in different genera and is of great importance for systematic purposes. The central part of each septum is flattened or slightly undulose, but the edges become folded or even frilled, often giving rise to very complex suture lines. By this means, greater support is afforded to the outer tubular part of the shell than is the case in the nautiloids, where the sutures are simple. The portions of the suture line which are convex towards the mouth of the shell are termed as saddles, where the intervening concave portions are known as the lobes. In many forms, the lobes and saddles exhibit secondary foldings which may be slight, producing merely a denticulate pattern, or may be deep and provided with other smaller foldings, giving a foliaceous appearance to the suture. The lobes and the saddles are nearly always similar on the two sides of the shell. Commonly, there is first the external lobe at the external margin, then the superior and inferior, or first and second, lateral lobes on the sides of the wall, and near the inner margin other lobes known as auxiliary lobes may occur. On the internal margin, opposite to the external lobe, is the internal lobe. The saddles are arranged in a similar manner. There are external saddles, the lateral saddles, and the auxiliary saddles. The external lobe is often divided by a median or siphonal saddle. Sometimes other lobes and saddles, termed as adventitious, are formed by the subdivision of the external saddle or of the median, that is siphonal saddle, in the external lobes or of the lateral lobe. With a few exceptions, the suture lines of one side of the shell are symmetrical with those of the other side. There is a relationship between the number of lobes and the saddles in the suture line and the form of the whorl. When the whorls only just touch and are circular or oval in section, usually only the fundamental lobes and saddles are present. But when the whorls overlap, there is a tendency to increase the number by the development of auxiliary and sometimes also adventitious lobes and saddles. The naming of the lobes and saddles according to their position in the adult shell appears to be less satisfactory than a terminology based on the study of the development of the suture line during ontogeny. From the development of the suture line of an hoplitid ammonite, it will be seen that the first lateral lobe is always a fundamental part of the suture line, but the lobe which is formed later at the umbilical suture subsequently gives rise by subdivision to a number of lobes on the external as well as on the internal side of the umbilical suture. When uncoiling of the shell occurs, as in baculitis, the elements of the suture line remain the same throughout life, namely the external lobe, the first lateral lobe, the second lateral lobe and the internal lobe. The form of the successive suture line remains almost constant on the adult part of the shell, but on the younger parts the sutures are less complex. The suture line of the first septum may be straight or only slightly curved as in the nautiloids, or it may show a broad external saddle or a narrow external saddle with a lateral lobe on each side. In the second and latter septa, the sutures become successively more folded until the adult form is attained. In the early ammonoids, the suture lines are comparatively simple. The minor subdivision or divisions of the lobes and saddles begin to appear in some Carboniferous genera. They increase in importance in the Permian and attain a great development in the Trias, where the ammonites commonly possesses very complex sutures. The acme of the complication is reached in the upper Triassic genus, that is the Pinacocerus. The gradual advance in the complexity of the suture line is shown in a series beginning with Anthracocerus from the Carboniferous and ending with Usuria from the Triassic. The protoconch of the ammonoids is formed of calcareous material. In a few of the straight or loosely coiled genera, it is spherical or ovoid in shape, but in most genera with closely coiled shells, it shows a convolute mode of growth and becomes barrel shaped. The first septum closes the aperture of the protoconch. The siphuncle commences with a bulbous enlargement, that is cecum, which projects into the protoconch. The cecum is attached to the opposite side of the protoconch by strands, that is the prosiphon. In the first few chambers, the siphuncle is variable in position and relatively large. In some times afterwards, it gets gradually nearer the external margin of the whorl and becomes relatively smaller than the body chamber of some ammonoids and goniatitis in the Aculatia and Scaphitis. A pair of calcareous plates known as eptychus are occasionally found. In shape, they are triangular or nearly semicircular. The margins where the two plates are in contact are straight, the others curved. Since in one ammonite an eptychus was found closing the aperture of the shell, it is probable that it served as an operculum and was attached to a part of the body representing the hood of the Nautilus. A similar structure, but consisting of chitin and with the two plates united is found in the body chamber of some ammonoids. In a few ammonoids, the shell is either a straight cone, for example Lobobactritis, or coiled into a helicoid spiral, for example Turrilitis, but in the great majority of the genera, all the whorls are in a plain spiral, and in such the form of the shell depends mainly on whether the latter whorls grow round the earlier, or are simply in contact with them or slightly separated. In some genera, the last whorl partly or completely conceals all the previous ones, but in others the whole of the whorls are visible, and then the umbilicus, which is present on both sides of the shell, is very large. When the diameter of the whorl from side to side, that is the thickness, is greater than the diameter of the internal to the external margin, that is the height, the whorl is said to be depressed. The umbilicus is then deep, and if in such cases the latter whorls embrace the earlier, then the umbilicus will be both deep and narrow. The whorl is compressed when its height is greater than its thickness. In some ammonoids, the outer whorl begins to uncoil, and this leads to or leads on to the scaphoided coiling, in which the body chamber is quite free, and to a hemitoid when the shell is bent upon itself in a crozier hook fashion. The extreme of uncoiling is reached in baculitis, in which only a small part of the shell is a spiral, the remainder being straight. The surface of the shell may be smooth or ornamented with striae, ribs, tubercles or spines. As a rule, the ornamentation is much more developed in the Mesozoic than in the Paleozoic genera. In some ammonoids, the external margin of the shell is provided with a ridge or keel, and in these forms the ribs of the two sides are not continuous. The keel may be smooth or toothed. In some genera, there is either a groove or a flattened margin in the place of the keel. The aperture of the shell in the ammonoids is frequently produced into lobes at the sides or into a pointed projection at the external margin. In some of the Goniatitis, there is a sinus at the external margin of the aperture, indicating a position of the funnel, but this disappears in more advanced types and with few exceptions is absent in ammonoids. The character of the ornamentation, the shape of the whorls, the position of the siphuncle and the form of the sutures change at different periods in the life of the individual. These changes, which occurred during the growth from the protoconch up to the adult, can be traced out by examining the early whorls of the shell. From a study of this development of the individual, that is ontogeny, attempts have been made to trace out the phylogeny of various types of ammonoids. As in the case of the Brachiopoda, it has been found that some forms which in the adult state appear to be nearly identical differ in their development, indicating that they have descended from different ancestors. Similarly, the development of the suture lines and other features of the shell shows that the ammonoids have descended from more than one group of Goniatitis. Since the ammonoids are extinct and their soft parts unknown, it is impossible to determine whether they possess one pair of gills as in the Dai Branca or two pairs as in Nautilus, that is tetrabranchia. As however the shell was external and agrees closely in structure with that of the nautiloids, and the muscular impressions in the body chamber are similar to those found in Nautilus, we may regard the ammonoids as closely allied to the Nautiloidea. This view of their relationship receives further support from the resemblance shown by the early ammonoids in their relatively simple sutures, backwardly directed septal necks, the sinus at the external margin of the aperture, etc., to the nautiloids. The protoconch of the ammonoids, however, resembles that of the belemnitis as much as that of the orthoceras, but differs from that of Nautilus. A striking feature of the majority of the ammonoids is a bilateral symmetry of the shell. This is characteristics of the animals which live with the median plane of the body in a vertical position. Such a position would be likely to follow from the hydrostatic effects of the air chambers. These in life would be uppermost and the body chamber below. The vertical position and bilateral symmetry are more likely to be retained in swimming mollusks than in those which live crawling on the seafloor. Swimming mode of life would be favored by the buoyant influence of the air chambers, and those with flattened shells and acute margins would experience less resistance in moving through water than those with convex walls. Broad round external margin and strong ribs. It may seem more probable that most of the ammonoids were nectonic and lived at no great distance from land, that is, on the continental shelf. They may be abundant even in very shallow water deposits. Some genera, however, such as Philoceras, Lithoceras and Archesters, have extremely thin shells comparable with those of the pteropods and other pelagic mollusks. These seem to have been still better adapted for swimming and floating, and may well have led a semi-pelagic existence. The different modes of the coiling seen in such genera as Crioceras, Turrilitis and Baculitis were probably related to the adoption of a more distinctly benthonic mode of life. This benthonic habit may also account for the partial loss of symmetry in a smaller number of ammonoids. In these, the siphuncle may be shifted from the median plane and the suture line of one side of the shell not quite symmetrical with that of the other. In Nipponitis from the upper chalk of the Japan, the early whorls are coiled like Turrilitis, but the latter whorls are quite irregular. It has been suggested that this was a fixed form, like Vermetus. Among gastropods, the wide geographical distribution of the species of ammonoids accords with a swimming mode of life, but with an external and chambered shell, it is not likely that ammonoids were capable of such rapid motion through water as are the dibranchs. Coming to the fourth module, that is the order Dibranchia. The Dibranchia are represented at the present day by the cuttlefishes, the squids, the calamaris, the octopuses, the paper nautilus, etc. They are of much less importance geologically than the nautiloids and ammonoids, the only really common fossil forms being belemnitis and its allies. Some of the modern cuttlefishes attain a length of the 40 feet or more. The Dibranchia have a sac-like or elongated body and possesses one pair of gills only and one pair of auricles. The number of arms is limited to 8 or 10, and on the inner side that facing the mouth they are provided with rows of sucking discs which sometimes possesses horny hooks. The jaws are not calcified and are consequently seldom preserved in the fossil specimens. An ink sac is always present and is sometimes found as fossils. The funnel is in the form of a complete tube. The eyes are highly developed. A shell is absent in some forms, but when present it is except in Argonauta internal, being covered by folds of the mantle and may be either horny or calcareous. In some cases, for example sepia, It has the form of an oval flattened body known as the cuttle bone, which is composed mainly of laminated calcareous material with spaces between the laminae. In the squids, this shell is lamellar in the form and consists of horny material. It is termed as the pen or glandulus. The shell in the cuttlefishes and squids is placed on the upper or dorsal side of the body in a sac formed by the mantle. In the spirula, the shell resembles that of a tetrabranch but is internal, being almost entirely covered by the mantle. It is situated at the posterior end of the body and consists of a tube coiled in a plane spiral and divided into chambers by septa, which are traversed by a siphuncle placed near the inner margin. The walls are not in contact and a calcareous protoconch is present. The shell in the paper nautilus, that is the Argonauta, is of quite a different nature to that found in the other dibranchs. It is internal and spiral but not chambered and is without muscular attachments. It is secreted by the terminal portions of the two anterior arms and is found only in the female, serving for the reception of the eggs. The dibranchia are divided into two suborders, the decapoda and the octopoda. There are 10 arms, 8 of equal length and 2 longer than the others. The latter can be more or less completely retracted within pits. Their free ends are swollen and suckers are usually borne on those ends only. The suckers are stalked and are provided with a horny ring. An internal shell is always present. Thank you very much.